Hello friends, I am Dr. Prof.Chishty and I am teaching physics to the BSc first year students. My today's topic is geometrical and physical optics. Now in this topic we have to study about the cardinal points of a lens or the lens system. So before studying the cardinal points, let us understand something about the lenses. We are having two types of lenses generally. It is our convex lens, it is the concave lens. Convex lens means a converging lens, concave lens means the diverging lens. Okay, so it is double convex, it is double concave. There may be plano convex, plano concave, different types of lenses are there. Now I will show you the three rules of a lens, that when a ray of light is allowed to incident at the optical center of the lens, then it will pass undeviated after refraction. There is no deviation. This is the principal axis and the ray of light is incident at the center, then there is no deviation. Second rule is that when a ray of light is coming parallel to the principal axis, this ray, after refraction it will pass through the focus on the principal axis. Then third rule, when a ray of light is coming from the focus, it will become parallel after refraction in case of the convex lens. Same rule will be applicable to the concave lenses. When a ray of light is coming parallel, allowed to focus on the center, allowed to pass through the center, it will pass undeviated. When a ray of light is parallel to the principal axis, after refraction it will diverge and you will get here the imaginary or the virtual focus. When a ray of light is coming through the focus, virtual focus, then after refraction it will become parallel to the principal axis. Now keeping these minds in rule, we can study the cardinal points of a lens system, and that too we will consider a thick lens. So let us study about the cardinal points of a lens system. For this purpose, I will consider a thick lens. Cardinal points. So I will consider here the thick lens. This is a thick lens and here is the principal axis. Now I will apply the rule. When a ray of light is coming parallel to the principal axis, then it will get refracted through the first surface, then it will also get refracted from the second surface and will meet here at the focus 2, F2. Now when a ray of light is coming through the focus, F1, which is allowed to incident here, then it will get refracted through the first surface, and after refraction through the second surface it will become parallel. Now I will extend. So here in this case we can say that F1 and F2 are the two cardinal points. These are the first two cardinal points known as the focal points on the principal axis. Now to find the principal points, I will extend this ray, I will extend this one, and I will extend the refracted ray. Okay, I am extending the incident ray and the refracted rays. So I will get here the 2 points. And from these 2 points, I will draw the perpendicular on the principal axis. This is the first perpendicular known as the first principal point. This is the second perpendicular known as the second principal point. So these P1 and P2 will be the principal points on the principal axis. Principal points on the principal axis. Okay, so these are the 4 points known as the 4 cardinal points. So what we have done, we extended the incident rays and the reflected rays. For the first principal point, I am extending this ray and I am extending this ray. The point of intersection, I am drawing a perpendicular on the principal axis. For the second focal point, second principal point, I am extending this ray and I am extending this one. So I am drawing a perpendicular from the point of intersection. These two are the principal points. These two principal points lie inside the lens, inside a thick lens. Now, what I will do, I will draw one perpendicular to the first focal point and perpendicular to the second focal point. These two perpendiculars are known as the focal planes. They are called as the focal planes. Similarly, these perpendiculars, that is H1 and H2, these perpendiculars are called as the principal planes. They are called as the principal planes. They are principal planes. So these are the four cardinal points of a thick lens. Now to study the nodal points, another two points known as the nodal points. So I will consider this system. Here there will be two principal planes inside the lens, and I will consider an object outside the lens. So to study the nodal points, when a ray of light is allowed to incident on one of the nodal point, it appears to pass through the second nodal point. It appears to pass through the second nodal point. For example, I am having these two principal planes H1 and H2, and I am having this one as principal axis. Here is the object. Here is the object. Now from this object, I am drawing a ray. I am incident a ray towards the first nodal point. I will incident this ray towards the first nodal point. Means nodal point is here N1. But this ray will not pass through the first nodal point N1, but it will pass through the second nodal point here N2. It will pass through the second nodal point. So similarly, if I draw a parallel light, then it will, after refraction, it will pass through the focus F. So here are the principal points P1 and P2. Here are the first nodal point N1 and second nodal point N2. So this N1 and N2 may coincide with the principal points if the system is kept in air. If the system is kept in air, principal points and nodal points may coincide. But for a two-lens system, they may be separated. For the two-lens system, if I am having two lens system which are separated by some distance, nodal points and principal points may not coincide. So in any lens system, in a two lens system or in a thick lens, there are total six cardinal points. Two are the focal points, two are the principal points, and two are the nodal points. So all these are combinedly known as the cardinal points of a lens system. Thank you.